welcome to my channel Rapid Vectors. In this tutorial I'm going to show you how to create an enemy state machine with different states so that your enemy can be in an idle state and then also chase the player. I will also show you the benefits of creating composition nodes to separate your code and make it easier to create other enemies. Please remember, if you like what you see, hit like or subscribe to receive more updates of future tutorials. Before we begin creating our new enemy dino and then adding the state machine, let's download some new assets so that we get the sprite sheets for our new enemy. So head over to the Sunnyland Chibi Enemies Pack 1 and let's download this sprite sheet. I will leave the link in the description below the video. And we will use this dino sprite for our enemy. In my previous tutorials, we have already covered the concept of a state machine in our player script and enemy script. In those scripts, we are already using an enum state which helps transition between the different behaviours for those characters. However, there is an alternative method to attaching different behaviours to our characters by using an alternative state machine by using composition. Now what this entails is us to add different nodes to the actual player or the characters which define those behaviours. So if we look at the flowchart here, what we are going to create is a state machine manager which we can then attach our states to, such as idle and attack, and then we will manage the transitions using a state machine controller. What you will see from the node tree is that it will be very easy to see what behaviours have been defined for those characters, and also you will be able to move those different behaviours between different characters so you are reusing those behaviours in the future. As you start to progress in your game development, you will be then able to reuse these nodes and be able to build characters at a much quicker speed. Now before we begin, let's open our test level. We'll use this scene to create our new enemy, and then just go to project settings, and in the run configuration under main scene, let's just set that to be the test level because we'll be continuously running this. We can always set this back to level 1 later. Now in the test scene, let's just clean up these previous enemies. And now we've set the scene for our new test. So let's begin creating our new enemy dino. If we just go scene, new scene, other node, and character body 2D. Let's rename that as enemy dino. Let's go to the enemies folder. And as you can see, we just need to tidy this up a little bit. So create a new folder, call that crab. And then click and drag the enemy crab items in there. Then click new folder, create a folder called Dino. And let's just, with the unsaved scene, let's just save that. And let's just pop that into our Dino folder. Now in the downloaded assets for the new Chibi enemies, let's grab those sprite sheets. When you've unzipped the enemy pack files, under the sprite sheets folder, we want to use the Dino PNG and the Dino Idle PNG. So let's just drag those into our folder. And once they're there, then create a new node and use animated sprite. Let's create our sprite frames again and create our idle animation and an attack animation. So under idle, let's add those frames. We'll go to Dino folder, Dino idle, and then select those frames. So control and wheel mouse in, and then we can play that. Let's zoom in onto the character. Let's make sure that's playing correctly. And then let's increase that. I'll say about 10 for that. And then for our attack animation, let's load the next sprite sheet and then choose our frames. We can zoom in again, add those frames, let's press play, and let's increase that a bit more. So we've got 12 frames per second. And that's about right. So for the idle, we'll put that on auto load. And then let's save that. Let's adjust the animated sprite so it sits on the y-axis a bit higher. So let's go to our position and let's just move that up. What we want it to do is to just sit on the x-axis line. Let's just play the two animations, make sure that the animation is hitting the line, which it is, so that's good. Let's stop that. And then let's have a look at adding our collision. So we'll say add child node, collision shape, and then just make this a circle. And then do the same, let's move that up, and we can leave that at that size. So now that we've added the collision shape, let's go back to the character, click on enemy dino node, and then let's scroll down. And what we want to do is to put this on the correct layer. So we have created an enemy collision layer in a previous tutorial. So we've got that set at number 3. So click that. And then you want to leave the mask at 1 so that this collision layer here detects the ground. So that's already set up now. We are now going to create our other behavior nodes for our character and then move on to creating the state machine. So let's create a child node and just choose node. And rename this to gravity. This will apply the gravity to the character so that it lands on the platform. Let's add a script for that, and we'll just save that script as gravity. And in the script, let's add some parameters. So we want our character body 2D and export that node so that we can attach the character. And then let's add the animated sprite 2D and we'll export that. Then let's add a constant variable for our gravity and assign a value of 1000 to the gravity. Then let's add a function which is the physics process function. And then what we want to do is check if the character is not on the floor, then let's apply velocity to the y-axis or the gravity. But if character body 2D is not on the floor, then let's assign some velocity to the y-axis. So we'll use our gravity variable and then multiply that by the delta for the frames. Let's head over back to the test level. And let's add our enemy to our scene. Let's just zoom in on that and just drag that over. And then let's play that scene. So what we need to do, we need to assign our enemy and the animated sprite to these two export variables. Let's just stop that, head back over to the enemy, and then click on the gravity node and let's just assign those variables. And then go back to test level and then run the game. And then what we need to do then is also apply move and slide. And then test the game again. And as we can see, the enemy now has gravity and has landed on the platform. We can now create our state machine for our enemy. So let's create a new node. So add child node and then choose node. And rename this to be state machine. Let's add a new script and let's save this into a new folder. Let's go to the scripts folder and then create a new folder and call this state machine and add the script inside there. Let's just check that. So we've got the state machine here. And then what we want to do is to make this our own class. So we're going to inherit from node and call this class name. We'll call the class node finite state machine. Let's create our ready method. And then let's create the process method. Then we'll create the physics process method. And a transition method. So before we finish this class and fill in these methods, what we need to do is to create a node state, and this will be the node that the state machine will manage. What I'd like to do first is just rename this class, rename the script file, sorry, to match the class name. So we'll call that node finite state machine, and then create a new script and call this node state. Let's open that script. And let's create a class using class name node state. And in this method, we'll call the functions on process. So it's not the same as the process method. we're going to call this from within the state machine. Another method called onPhysicsProcess, an enter function, and an exit function. And save that. We can now create our first state for the state machine. Let's go back to the enemies folder, click on Dino folder, and on the state machine, let's add another child node. So choose node and call this idle. And let's attach a script to this node. So we'll attach script and call this idle state. In the idle state script, where it says extends node, we want to change that so it extends node state. And then we need to pass in two variables from our enemy, which is the character and the animated sprite. So we'll say export for character body 2D and export the animated sprite 2D. Then open up the node state script and copy these methods into the idle state script. And in our onPhysicsProcess, what we want to do is when the character is in the idle state, we want to make sure that the velocity is slowed down to 0 so it stops, and that we're playing the idle animation. And then we need to call move and slide. And then export another variable for our slowdown speed. And we'll set this to a default value of 50. Now go back to the enemy dino, and on the state machine, add child node, click node, and let's rename this as attack node. And let's add a script. And then call this script attack state. And go back to the node state script and then just copy that and then pop that into your attack state script. And then we want to extend from node state, so we can just remove that. Now that we have two nodes for our state machine, let's go back to the state machine script and let's now fill in these functions here. So let's start by setting the initial node state for the state machine. Let's export that variable. We'll call this initial node state. And then let's hold the node state into a dictionary. So create a dictionary variable. And then we need to hold what is the current node state that the state machine is currently active with. So another variable called current node state. And then we'll do a check later for the current node state name. So let's create another variable which holds the current node state name. So when the state machine starts, we need to use the ready method to get the states from the state machine and build that collection. And what we'll do, we'll pop those states into the node states dictionary. So let's create a for loop here. So we'll say for child in get children. And we'll get these children here from the state machine. And then we'll say if child is node state. So if the child is of that type, then let's pop it into this dictionary here. And then we'll give the key name the name of the actual state. And to be safer, we'll always make sure that the name is made lowercase so that we can pull that back later. It then doesn't matter what you name this node, it will always use that lowercase. And then say if initial node state, and then initial node state, we want to then call the enter method, which is this one. And then set the current node state. Now in the process method, we need to say if current node state, then current node state call its onProcess method and pass in delta. Which is this method here. And we're going to then do the same for the others. So let's copy this one for the physics process method. But we want to say onPhysicsProcess. So we'll say print current state, then use current node state name to lower. And then for the transition to method, let's pass in node state name. And then check if node equals current node state dot name dot to lower, and then let's return, because if we've already got the node, then let's not call it again, and we'll say new node state equals node state.get, and if not new node state will return, and then if current node state, we want to then exit that node. So when the new one comes in, let's exit the current one, because what we're going to do straight after that is with the new node state, we'll enter that. And then let's say current node state equals new node state. And then the final thing is current node state name equals the current node state name dot name to lower. Now let's head over to the test level, and in the 2D scene, what we'd like to do is when the player runs across a platform, there is an attack area around the enemy, and once the player steps into that area, the enemy will chase the player. So let's go back to our enemy and add a child node. Call this area 2D, and we'll rename that as attack area. Add a collision shape, and for this collision shape, let's make that a circle, and we'll just change the color of it too, so that we don't have two collision shapes with the same color in the same scene. And let's just move that, let's just make it a little bit larger, pop that into the center, and then let's make this much larger. So this is the attack area. So once the player steps into this area, the attack state will begin, and then the enemy will start to run at the player. Click on the attack area 2D node, and in the collision layer properties, let's just uncheck the ground layer. Let's check the enemy layer because the attack area is on the enemy layer, and what we want to do is to be able to detect the player. So in the mask, set layer 2 and then turn off the ground layer, layer 1. Now that we've got the state machine with 2 nodes, we've set up the attack area. We still need to set up the attack functions. But what we'll do is let's create a state machine controller that can switch from the idle state to the attack state, and then we'll finish the attack script. So add a new node, and we'll use node, rename this, call this state machine controller, and we'll just pop that above the state machine. Now attach a script, and we'll save that in the dyno folder. So state machine controller, and now we want to pass in the state machine to our state machine controller. So export the node finite state machine. So at export for node finite state machine. And we should now attach the attack area 2D so that when the player steps into the area, we attack, and when they step back out the area, the enemy goes back to idle. So in the attack area node, let's go over to node, and then what we want to use for these two methods is the body entered and the body exited. So for body entered, click connect, and then connect it to your state machine controller script. And then let's do the same for our body exited. Now we only want to check that the body that enters this area is the player. So we can do that by using a group. So head over to the player script, or the player scene, sorry. Open the player scene, and when you click the player here, we need to pop that player into a group so that we can pull it from the node tree. So go into groups and then just add player as a group, and then add that, and that will assign it to this node. And you can see that by this new icon that's been added to the node, and just hover that node and it says node is in this group for player. Head back to your enemy, and in the attack area, what we can do is in the body function, this is of type node 2D, so we'll just statically type that, and this will then help us with our method. So we'll say if body is in group, and the group we're looking for is player, and what we want to do, we want to get the node finite state machine and transition to attack. Then copy and paste this and pop it into the exited method. And then if body is in group player again, we want to node finite state machine and transition to idle. So now that we've created our base scripts for our state machine nodes, what we need to do is link up the export variables which we've been creating. So let's just first check these. So let's start with our state machine controller, and in the inspector, let's assign. So assign the state machine, and then on the state machine, we've already assigned the initial node state, so this is set to idle. And then on the idle state, we've currently set the character body 2D and the animated 2D with the default value of slowdown speed of 50. And on the attack, we've currently not set that up yet because we're going to come back to that script. So go back to test level, 2D scene. Well, before we run the scene, let's switch on our visible collision shapes. So what we can see is when the player shape or collision shape on the player is moving into the attack enemy shape. So let's just run the game. And let's just move slowly. As you can see in the output messages, the current state of the state machine is idle. And then as we move into the area, you can see that this is now changed to attack. So the state machine is now working and it is moving between those two states. So what we'll do next is finish the attack script so that the enemy starts to chase the player. Let's stop that. So head back to the enemy dino scene and then click on the attack script and let's start to fill in this script so that the enemy is chasing the player. The first thing we want to do is when the state is active and is entered, we need to get hold of the player. So we'll create another variable here called player. And then in the enter method, we'll say player equals, and then we can get the tree and then get nodes in group and then call player. So we added that player to the group. And because this is a collection, there's only ever going to be one player in this group. So we can just call index 0 from that list. And we say it as character body 2D. Then let's export the character body 2D and animated sprite so that we can control the velocity and the animation. And at export the animated sprite 2D. And then let's export a speed variable. Now in the onPhysics process, what we first need to do is to find the direction at which the player is entering the area. So what we can do is we can say, get the character body's current global position and then say if that is less than or if it's greater than the player's position. What we can then do is get the direction. We can flip the sprite and then we can apply the velocity as well. So we say body direction and then if character body 2D, and then say else if is the character body global position is less than the player's global position, then we'll have a different flip and the direction will be different. This will then go into our velocity function. Then flip the sprite and then direction equals 1. Once we're in this method, we want to then call the attack animation. And then let's call the velocity X and make a modification to that and then move and slide. So we'll say character body velocity. And this is very similar to the player's velocity and movement. And then what we want to do is we want to clamp a maximum speed to that. We can do that by saying character body 2D velocity.x equals the clamp function. And the last thing we need to do is to move and slide. So let's click the attack node and let's assign those variables. So we want the enemy dino for the character body and then assign the animated sprite 2D. And then let's give a custom speed here and we will say 200. Let's run the game. Okay. So as you can see, it's quite fast and the sprite is flipping in the wrong direction. So let's stop that. So let's just reverse these two values. So we'll flip false here and true here. And let's just pop this to half the speed. Let's run the game again and let's see what effect that has. That's a little bit better. And as you can see, the enemy stops, but there's a pause and a slide. So what we'll do, let's stop that. And let's go back to the idle script. And we have a slowdown speed here that's set to 50. So let's just modify this variable and put it to something much higher. Let's run that game. And as you can see, when you enter and then come out of there, it's still sliding. Let's try that a little bit higher again. Let's say 300, enter, run the game again. And as you can see, there's a better stop on that. So you can modify that slowdown speed to get the desired effect. What I'd also like to do is to use an improved clamp speed for the max speed. Let's just stop that and we'll just go back to the attack script. Let's create another variable here called max speed and then set the max speed here. So we'll use the current speed value that you've set and then we'll just add 20 to it and then replace the speed variable here. Let's run the game again. And stop that. So just head over to the debug menu and then invisible collision shapes, just turn that off and then let's run this one more time. So as you can see that the enemy is now chasing the player. If we look at this enemy dino and compare it to the enemy crab, you can see that the states in the state machine make it much more clearer on what the behaviours this enemy has. The other benefits are, if we create another enemy, we can share these states between them so that it becomes quicker to create enemies for quite a large game. Well, this brings us to the end of this tutorial. If you like what you've seen, please remember to hit like or subscribe and then receive updates from my other tutorials. Thank you for watching.